Hello and welcome to our lesson on development of the atomic theory. This lesson is particularly useful for physics as well, as it covers the same information. You're going to need to know some names of people and what they did and how their experiments led to certain conclusions. So let's make a start. So the theory really started about 500 years BC with this Greek guy here, Democritus, and he came up with the original atomic theory. He believed that everything is made of tiny particles, and those tiny particles can't be broken down any further. They're a solid sphere, and they are separated from each other by empty space. And that's as far as his theory went. It was over 2,000 years later when any serious work started to occur with the atomic theory, and this guy here, John Dalton, in the 1800s, was the first person to pick up these ideas and to start suggesting new ideas or more in-depth ideas. So John Dalton suggested, just like Democritus, that atoms were all solid spheres. They couldn't be broken down into anything smaller. But he also suggested that atoms are the same elements. We already had this word element, recognising that iron was different to oxygen, was different to gold. But atoms are the same element, all have the same sphere. The sphere for gold was always the same shape and size. And he also predicted or suggested that atoms of different elements, the spheres would look different. So a gold sphere or a gold particle would look different to an iron particle, which would look different to an oxygen particle. A few years later, in 1897, this man here, J.J. Thomson, discovered through various experiments that these atoms couldn't be solid spheres. There was something inside, and he discovered that these were negatively charged particles, which he called electrons. So J.J. Thomson discovered electrons. His model was called the plum pudding model. I always think JJ is double J and plum pudding is double P. But the plum pudding model was this idea that the entire atom was a ball of positivity, positive charge, and that the negative electrons were kind of scattered throughout. I guess if he had invented this theory in modern days, he might have called it the chocolate chip cookie idea, where the positive charge is the cookie and the electrons are the chocolate chips within it, but they were scattered throughout. So Ernest Rutherford actually worked with J.J. Thomson, and J.J. Thomson asked Rutherford to help him to run some experiments and to collect more data to prove his plum pudding model. Rutherford then carried out a very famous experiment known as the gold foil experiment, and you need to know this in detail. I'm going to do this in a separate video because otherwise we'll run forever. So just watch out for that video on the gold foil experiment. But Rutherford, along with his lab assistants Geiger and Marsden, carried out the gold foil experiment and realised very quickly that the plum pudding model couldn't possibly be true. So Ernest Rutherford proposed a new theory or a new model where instead of the entire atom being positive, he suggested that there was a very small, compact nucleus in the centre where all the positive charge belonged. And the electrons, while they weren't scattered throughout, he proposed that the electrons were kind of around the outside of the nucleus, so this cloud of electrons. Now, the problem with this model, even though it's pretty good and it's pretty much what we look at today, the problem with this model here is that it really didn't explain how atoms remain stable. So with Rutherford's theory here, the electrons just being outside would have caused the atom to collapse internally. And so this model was great. It was a lot better than plum pudding model, but it was by no means perfect. It wasn't long after, just a few years later, that Niels Bohr came up with an idea that the electrons, instead of just being in a cloud around the nucleus, actually orbited, so went round the nucleus, a bit like the Earth goes round the sun, orbited the nucleus, so kept on moving, and were actually held in shells, or what we would call as energy levels. And this solved the problem of an atom collapsing in on itself. And that made much more sense. So this looks very similar to what you might recognise as today as the structure of the atom. After that, Ernest Rutherford was still doing more work. He discovered that this positive charge inside the nucleus was actually protons. So he discovered the protons. And then a little bit later, James Chadwick discovered neutrons also inside the nucleus. So these guys together over time built on each other's ideas, changed each other's ideas as new evidence came about. And that's an important part of this. Why do these theories keep changing? Why do these models keep changing? Well, because we keep coming up with new evidence that changes our ideas, and we have to change the models to fit that new evidence. Otherwise, it's not science. Okay, so let's do a quick quiz. If you write down 1 to 10, obviously not in your book because you've probably not got a book in front of you, but 1 to 10, and let's see if you can name the scientist. Okay, number 1, who first thought atoms were indivisible? Number 2, who discovered electrons? Number 3, who discovered protons? Number 4, who discovered neutrons? Number 5, who first suggested that each type of element had its own type of sphere? Number 6, who created the plum pudding model? Number 7, who disproved the plum pudding model? Number 8, who suggested electrons orbited in shells? Number 9, who created the nuclear model? And number 10, who was the first person to suggest an area of positive charge? Okay, hopefully you've had a good guess and you've got down your answers. Let's check, see if you're right. So who first thought atoms were indivisible? Well, that was Democritus, the ancient Greek guy. Who discovered electrons? That was J.J. Thomson. Who discovered protons? That was Mr. Rutherford. Who discovered neutrons? James Chadwick. Who first suggested that each type of element had its own type of sphere? That was John Dalton. Number 6, who created the plum pudding model? So PP was J.J. Thomson. Number 7, who disproved the plum pudding model? You've got to think J.J. Thomson was pretty annoyed, haven't you? But that was Ernest Rutherford. Number 8, who suggested electrons orbited in shells? That was Niels Bohr. Number 9, who created the nuclear model? That was Ernest Rutherford again. And who was the first person to suggest an area of positive charge? Well, not a positive nucleus, positive charge. That was J.J. Thomson. Okay, I hope you got at least some of those correct. If you didn't or you got muddled up, hopefully that's kind of set you straight and has been a useful revision. Okay, let's move on. Okay, so I'm going to go through some exam questions with you. I suggest you pause the video each time, give it a go yourself, and that way you'll learn from your mistakes rather than just copying me. So pause the video, have a go. Okay, so the question, what did J.J. Thomson discover that showed not all of Dalton's ideas were correct? Well, J.J. Thomson only did 2 things that we talk about. He did the plum pudding model and he discovered electrons. And the answer is going to be electrons. So this is following on from that first question. It's part B. Rutherford did some experiments about the structure of the atom. Explain how Rutherford's experiments showed that not all Dalton's ideas were correct. Well, let's just book this question. So it says explain, that's our command word. That means we need to say something and we need to give a reason for it. Well, what are we explaining? How Rutherford's experiments. So Ernest Rutherford, so what was his experiment? It was the gold foil experiment. Okay, so how did his experiment show that not all Dalton's ideas were correct? So again, Dalton thought that atoms couldn't be split. So how did Rutherford and his gold foil experiment the nuclear model with that positive nucleus and the cloud of electrons, how did that show that Dalton's ideas were not correct? Well, have a go. And the answers allowed from the exam board, you could have said he split the atom, he discovered a nucleus, which was part of the atom, he showed that a nucleus was positive, or the idea that he showed the atom had lots of empty space. Now, we haven't actually covered that one yet because you are not on the video to do with the gold foil experiment, but you could still pick up 2 marks there. Notice it ignores references to protons and neutrons because they weren't part of Rutherford's original experiment. It says allow show that the atom was not a solid mass. So even if you recognise that Rutherford proved it wasn't solid, you would have picked up 1 mark. Okay, next question. Many scientists have been involved in the development of the periodic table and the structure of the atom. Draw a line from the name of the scientist to their discovery or idea. So pause the video, have a go. Okay, so if this was me in an exam situation, I'd be looking at this list of names. I would read through all the ideas just so I know what's out there, and I would start to kind of think, which one might that be? And I would go for the ones I was absolutely sure of first. So for example, I know in my head that J.J. Thomson discovered the electron. That is in my head. Rutherford was a big name. He was the nuclear model, so he's going to be the nucleus. Where does it say nucleus? Atoms had a nucleus, that bottom one there. So Rutherford and atoms have a nucleus surrounded by electrons. Yes, I'm happy that's Rutherford. Okay, now Bohr, I know Bohr was something to do with shells, electron shells orbiting. So let's have a look. Atoms was the smallest part of an element. That's not right. Periodic table. There. Electron orbits or shells. So I'm happy with that one. And you can see what I'm doing. I'm narrowing down the options with the ones I'm not entirely sure about. So here I've got Dalton and I've got Mendeleev. We've mentioned Mendeleev. So, and I've got 2 options. One is atoms were the smallest part of an element that could not be split. And I've got the periodic table. Well, we've not talked about the periodic table and we've not talked about Mendeleev. So I reckon Dalton is that one there and Mendeleev is that one there. And of course I'm correct because I'm a science teacher. Moving on. Okay, so this sort of question comes up quite frequently. The early theories of atomic structure were replaced by newer ideas. Explain why. So we are commanded to explain. So say something and give a reason. So explain what? Explain why what? What am I talking about? Well, things have been, or theories have been replaced by newer ideas. So why do we have new theories? Why do these guys keep changing the theories? So what do you think, guys? Pause the video, have a go. So the exam board allowed these options. Any of the kind of the idea, so it's quite an open and ended answer here. So the idea that we've got more evidence, or the idea that experiments show that the earlier theories were incorrect would get the mark. If you look on the allow side, allow the idea that more experiments have been carried out. Allow that we've got better equipment or better technology available. Allow the idea that more scientists looked at the evidence. So you can see here there's quite a wide range of answers, but the idea is we've got new evidence, so we change our theories to suit that new evidence. So the last one here then, pause and give the question a go. So in a multiple choice question, if I'm not sure, or even if I am sure, I would always read through all my options and then I would get rid of any silly answers and kind of try to narrow down my chances. So it says, which of Dalton's ideas are now known to be incorrect. So Dalton's idea was this solid sphere. So a chemical reaction is a rearrangement of atoms. Well, yes, it is. So that's not incorrect. It's actually a correct statement. All matter consists of atoms. Well, that's a correct statement. Atoms cannot be subdivided. Yes, they can. We can always make them into protons, neutrons, electrons. So that's a wrong statement. So that might be okay. And then D, when elements react, their atoms combine in simple whole number ratios. I have no idea what that means. Well, I do, but I'm pretending. So my logic, so I've narrowed it down to C or D. I know that C is an incorrect statement. D I'm not sure about, and so I'm going to go for C, and you know what, I'll be right. Okay guys, I hope this has helped. Don't forget to watch the video on Rutherford's gold foil experiment. Bye.